Welcome to another video in the graph series. Today's question might make you go like, how will I realize that this is a graphs question? And I completely get it. But it is better to learn while practicing than make mistakes in the interview, correct? And once you do 2-3 of these questions, you will get the intuition and you will start thinking in this direction. I know right now you know that this is a graphs question because it is in the graph series. But I will explain you how you can think of these questions. And it's a very good question to be asked in an interview because it is based on a very simple basic graphs concept, but it will make the interviewers see that whether you can see and you can think in a particular direction or not, or will you freak out and leave the question. So this is a very good question, do not leave it, and I will be writing the code in both C++ and Java. Let's get started. Before we move ahead, I would just like to take a moment to remind you to be consistent and make sure you do not miss any videos in the graph series. So make sure you subscribe, hit the notification bell icon. You will also stay motivated and you have no idea how much your support will mean to me. There's so much of free content available on the channel. There's HLD, LLD, DSA, Advanced C++, tutorials, mock interviews, and so much more. So if you think I deserve your support, please subscribe, hit the notification bell icon. And there's obviously a bunch of stuff that I cannot do on YouTube, like mock interviews, live interactive classes. So we have educourses.com. We have live courses, self-paced courses with live doubt solving support, which both of them we have mock interviews, and we have a lot planned in LLD, HLD, Advanced C++, DSA, and so much more. You have no idea. So if you want me to be part of your further learning journey process, please check it out. The link is in the description. And now let's continue. So this is the question that is given to us. Note that nowhere we are given that it is a graph. What is given to us? We are given two integers, n and k. What does n and k mean? Here it is given, we have to return an array of all integers of length n. So here you can see the length of every number in this array is n. Here it is 3, 3, 3, 3, 3. Here it is 2, 2, 2, 2, 2. Okay, so we are given n. We understand the meaning of n. Difference between every two consecutive digits is k. So you can see the difference between 1 and 8 is 7, 2 and 9 is 7, 8 and 1 is 7. Similarly here 1 and 0 is 1, 1 and 2 is 1. So difference between every two digits in a particular number. So this is one number. Difference between any two digits is basically equal to k. We may return it in any order. Now I know, like once you look at the question, you might get stuck that how do I even approach this question? So one thing that you really have to absolutely ingrain in your head, it is that DSA has very limited number of topics. They cannot come up with a completely new topic all of a sudden like that, okay? So what are the limited number of topics? There's recursion, there's DP, there's binary search, there's window sliding technique, there's trees, graphs and things like that, right? So you'll start thinking, can I form a search space? Can I do binary search? Or, can I do window sliding over here? Or can I form any relationship to maybe go ahead with tree and graph? Let's think about it. So if you see the first numbers over here, okay, so the first number can be 1, 2, 3, 4, 5, 6, 7, 8, 9. It can be anything. The first digit in any number, the first digit. Here you can see it is 1, then it is 2, then it is 3, then it is 4. So suppose we fix any digit, right? Because we have to return all the array of all the integers where these two conditions are met, okay? So to consider all the possible answers where these two conditions are met, the length should be n and the difference between the digits should be k, okay? So we know that the first digit can be anything. Now we also know the relationship between the first digit and the second digit. Whenever we have a relationship, okay, some sort of relationship. So basically it is like what? It is like these two digits could be nodes of a tree or a graph, and this relationship that the difference is k will be the edge, will be the connecting factor. Now the question comes, is it a tree question or is it a graph question? So how would we understand that? Let me repeat. So first thing that we understand is that the first digit in the numbers can be any digit. It can be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have a relationship between the first digit, second digit and so on. So maybe we can do trees, graphs. We will analyze this more. But also you have to start thinking of edge cases also. So when we form integer, when the starting digit is 0, it is a special case, right? Because what does 0 to mean? Is it 2 only? Is it possible to add 0 in the starting? Know that in questions in LeetCode, it might be given to us, like over here it is given that you should not have leading zeros. So the first digit should never be 0. It can be 1 to 9, anything. It can never be 0. Correct? Now in interviews, you have to ask these questions. These might not be mentioned, and that is why a lot of interviews give you half information. They do not give you the entire information. You have to think like this. So whenever an integer question is given to you, always have to think of zeros. Can zeros be in the starting? Can it be in the end? Can it be middle? What is, like, maybe the sum can be 0. So you always have to think of zeros. You always have to think of negative numbers and things like that. These are the common cases. You will get used to them as we practice more. Okay, so here also one more thing, note that we can start from 1 to 9, but here we are not always starting from 1 to 9. There are some scenarios, suppose 3, 4, 5, 6, we are not starting any numbers with 3, 4, 5, 6. Why is that? Why are we not starting? So let's think of that as well. So these are the two examples that are given to us. We already discussed that each digit can be a node. So let's try forming that. Suppose I form nodes like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. They can also be 0, right? So in this, here if we see the first example, it is given at 1, 2, 7, 8, 9, right? So we said we can start from anywhere, but first let's form the graph. Now in the graph, what is the relation? That the difference between any two numbers should be 7. K is 7, okay? Now if we think about this, is it undirected or is it directed graph? Now here if we see, we are also going from 2 to 9, but we are also going from 9 to 2, right? Because the difference between these two digits is also 7. The difference between these two digits is also 7. So we can go from 2 to 9 also and from 9 to 2 also. So this is what? This is bidirectional. So this is what? Undirected graph. So these details are very important. That is why basics of graphs are important to form the graph, that okay, is it directed or not? And here we also have to think that is this a tree question or is it a graph question? Right? So can we end up with a loop? Can we end up with cycle? Is there children over here or are they neighbors? So this actually makes more sense in terms of neighbors and adjacent nodes, right? So let's think about it. First, let's start connecting the edges. So for 1 will be connected to what? 1 will be connected to 1 plus 7. 1 plus 7 is what? It is 8. So I will connect this. Also 1 minus 8 is a negative digit, right? So I cannot connect to that. 2 plus 7 is what? 9. So I am going to try connecting 2 plus 7. 2 minus 7 is negative. 3 plus 7 is 10. Cannot have that. 3 minus 7 cannot have. 4 plus 7 cannot have. 4 minus 7 cannot have. And now it makes sense why we do not have numbers that are starting with 3, 4, 5, 6. The plus 7 and the minus 7 are not single digits, right? Similarly, let's say for 7. Now 7 minus 7 is 0. 7 plus 7 is 2 digit, plus 7 minus 0 is actually 0. So let me just take this out for a better diagram and let me draw it over here, correct? So I can draw it like this. Similarly, 8, if I see, I have already connected 8 to 1, I have already connected 9 to 2. So these are the only 3 edges. And if I start like this, so if I have to start forming the numbers now, the first digit of these 3 digits, I can fill with any digit, 1, 2, 3, 4, 5, 6, 7, 8, 9. I cannot start with 0, okay? So I start like this, and now let's see. So here, what can be my next number? So I can either do what? To do traversal. So I have to do traversal over here. Who is the adjacent node or the neighbor now? So for 1, there is 8. So I can add 8 over here, right? Then I will say again for 8, what can I add? I can add 1. Similarly, for 2, I can add 9. For 9, I can again add 2. So we are going to the neighbors. 3 is not connected to anything, so this doesn't make sense because I have to have the number of digits as n. This I cannot have, this I cannot have because it is not connected to anything, right? This is not connected to anything. 7 is connected to 0, 0 is connected to 7. 8 is connected to 1, 1 is connected to 8, 9 is connected to 2, 2 is connected to 9. So I hope you have understood how this works. And yes, we can do both DFS and BFS over here. We basically have to do traversals. Yes, let's try writing the code now. We have to return vector of integer. So let's quickly write that vector of integer res, and that's what I will be returning in the end. Now here the starting point is what? We have to start with adding the first digit. Now first digit can be what? It can be 1 to 9. Now rest of the digits can be 0 also, but here the first digit we have to always see it can be 1 to 9. So I'm just writing a for loop that my first digit, you can call it anything, I'm just calling it number, that this number is going from 1 to 9. So basically this is my starting number. In the end, the numbers that I'm going to add to the res, that should be of the length n, right? So number plus plus. And firstly, I'm writing the code using DFS. So what I'm going to do is I'm going to write a function DFS where I'm going to pass the current number that I have, the new n value. So in this number, there's already one digit like 1 to 9. So the rest of the numbers, what can be the length of the rest of the numbers? It can be n minus 1, correct? K I will pass obviously as it is. And obviously we have to pass the res. So now let's try writing this function. Do we need to return anything? No, right? We just need to fill the values in the res in the end. So I'm just returning void. And then in this DFS function, I am passing this num. So integer, this is the present number that I have. Then this is the n value that is passed to me, the k value, and then the vector that I'm supposed to fill, correct? Now DFS is nothing but recursion. So what do we have to do? We have to see how we can divide it into smaller subproblems and what will be my stopping point. What will be my stopping point? What is the goal? That the length of every number that I'm supposed to put in this array should be 3, should be n, correct? And I'm reducing the n. I started from n, then I passed n minus 1. Now every subproblem I'll keep passing n minus 1, n minus 1. Where will I stop? When my n becomes 0, correct? So that will be my terminating condition, my base condition when I'm going to stop my recursion. So when my n becomes equal to 0, that means I have a number that I can put into res. So what am I going to do? I am going to put this number into the res and I'm just going to return because I don't need to do anything else. I have found my number, now I am adding it to the res. Otherwise, whatever is there in this number, now the last digit I have to take and I have to do plus k minus k. Okay, now think about this, that my number presently could also be 29. Initially it was 2. In the next recursive call it would be 29. In the next recursive call it will be 292 and so on, right? So at any recursive call, it can be of any length, right? Whatever length we have already formed, how many ever recursive calls we are done with. But we have to see whatever is the last digit and then see in comparison to that. So I am just taking out the last digit like this. So my last digit will be what? It will be num mod 10, correct? So this is the last digit that I have to play with. Now the next digit that I am going to add will be last digit plus k or minus k. Yes, so there are two cases. One case is when I do plus k, one case is when I do minus k. When I do plus k or minus k, what is the condition? The condition is that when we do plus k or minus k, the value should still be between 0 and 9. It should be a single digit number. Otherwise, it will, suppose it is a double digit number or if it is negative, then it cannot be a particular edge, correct? Then it is not right. Note in this question, we are not actually forming a graph, but we are thinking in terms of a graph. That yeah, we are forming a graph and now here itself we can see that if there is an edge or not. You could actually form the graph, but that is not needed because here I know when there is an edge, when there is not an edge, right? Basically, I need to go to the next recursive call. I need to go to the next neighbor now. So how am I going to do that? Firstly, I need to check that whatever this last digit is, if I do plus k, I have to make sure that it is between 0 and 9. When I do plus k, the only thing that I have to check is that it should not be greater than 9, right? I am obviously not going in the other direction, so I do not need to check that it is greater than or equal to 0. I just need to check that it is less than or equal to 9. Once I do this, now I have to make my next recursive call. This will be my next subproblem. Now in my next subproblem, what is going to be my new number? So whatever number I had into 10, because now I am adding the new digit. What is the new digit? It is last digit plus k, correct? This is my new digit that I am adding. We are sure that it is a single digit number because we have added this check. And whatever was the previous one, so if it was 29, I have done 29 into 10, so it became 290 plus 2, correct? Actually, we are doing plus k, so you can think of the condition. If it was 81, I have done 810 plus 8, like that, okay? So this is my new number. Now what will be my n? I will be reducing it by 1. K will remain same, res will remain same. Similarly, I have to do for what? I have to do for minus k. Because I am doing minus k, what should I check? That it should be greater than or equal to 0 to be sure it is between 0 and 9. So what will be my next recursive call? It will be number into 10 because I am doing say 29. 29 into 10 it is 290 plus last digit minus k. So this is the new digit that I am adding. My n value will become n minus 1, k and res. So we are actually done with the code, but this is an edge case and I want you to think of it yourself. Think of this edge case. For this edge case, you really have to see about the constants. Here k can be between 0 and 9 also. What if k is 0? Then how will your numbers look like? Always 0 can be an edge case in integers, we have to think of it. So here, what are the numbers? Suppose k was equal to 0. Suppose, for example, if k was equal to 0 and suppose n was equal to 3, okay, then we could have started like 1, 1, 1, it could be 2, 2, 2, it could be 3, 3, 3. Now the thing is that from this one, when you do plus k and when you do minus k, you get the same answer, right? We get the same answer. Now this is a question again for your interviewer. Am I supposed to return 111 2 times, or am I supposed to return it only a single time? Because when you do plus k and when you do minus k, you are getting the same digit, correct? So in this case, it is not given that we have to return it 2 times. So we have to add a check that minus k I am going to add only if k is not equal to 0, and it is the case, okay? If k becomes equal to 0, I will not consider this condition. I will consider only the first condition. Let's try running it and see. So we have passed all the test cases. Let's submit and see. Awesome. But it is important that we understand the BFS code as well. So we are going to try writing that also. Don't be very happy. It is important that you are comfortable in writing both DFS and BFS. So again, we have to return vector of integers, and I'm going to call it res, and in the end, I'm going to return res. Now in BFS, what do we use? We use a queue. In this queue, what am I going to put? Is there any node as such? No, right? Every node is actually represented by an integer only. We are not actually forming a graph. Every digit itself is our node. So I am forming the queue of integers and I am calling it queue. Again, what is our starting point? We will be pushing all the digits first. What digits? From 1 to 9, not 0, right? So I put I equal to 1, I less than or equal to 9, and I plus plus, and I push all of them to the queue. So I have pushed all the I. So first digit is pushed. And how do I do the BFS? I have to iterate over the queue, right? So I will go like while queue is not empty. When it comes to BFS, there is one very interesting point. How will I come to know that the number of integers has become n? Now this is a problem, right? So first thing that we have to realize is that the number of levels that we go down in the tree or the graph is actually your number of digits, right? So when you go from 1 to 8, you're going to the adjacent node. So that is your one level. Then there's another level, right? So how do you go in BFS? You go breadth-wise. So first level, second level, third level, fourth level, you can think like that. So the first level, you have added 1, 2, and so on. And in the second level, you will be going from 1 to 8. And in the third level, you will be going from 8 to 1. Similarly, from 2 to 9, 9 to 2. Right? So you have to take care of what? You have to take care of levels. So we understand that, okay, we have to see that the number of levels becomes n. Let's do one thing. Let's first write the normal BFS code and let's see what change we would have to do to track the number of levels that we have gone down. Okay, what do we do in BFS? First, we take out the first element, the frontmost element in the queue. So let's do that. So I am going to call it f itself. So this is my frontmost element. Remember, in C++, front is there, but after that you have to pop also, right? You have not removed the element yet. So now I have removed it. Now I have the number. Remember that it can be any number. Suppose in the front it could have been 81, it could have been 70. So now for the next digit, I have to take care of the last digit of this front, okay? So if you want to call it, you could also call it current number, right? Now what am I going to do? I am going to take out the last digit from this. How is that? So last digit is basically current number mod 10. Yep, so I have the last digit. Now in order to add to the queue, what do I have to do? I have to go to last digit plus k or minus k. But the conditions are going to remain same to add to the queue. So if my last digit plus k, if my last digit plus k is less than or equal to 9, only then I am going to add to the queue, correct? So I am going to push to the queue. And what will be my new number? My new number will be whatever is my current number into 10. So if it was 29, 29 into 10 plus last digit plus k, correct? Similarly, we have to check for minus k also. Again, k can be 0 as well. So we have to add that check that k is not equal to 0 and last digit minus k is what? It is greater than or equal to 0. So if that is the case, I can again call for what? In my queue, I can push current number into 10 plus last digit minus k. That is going to be my new number. So this is how my normal BFS looks like. But I have no idea when to stop this. I cannot keep on going till queue is not empty. I also have one more check that n should be equal to 3. I know that my number of levels is that. Now, how do I track number of levels? Because the problem that is happening over here is that when I am removing a number from the queue, I'm not sure at how many am I adding, right? Because suppose I have removed 3 from the queue right now, but the 3 plus 7, 3 minus 7, I am not pushing it to the queue. So I have no idea when that my number size is becoming n. One thing that you could do is you could add a check that, okay, is the current number ka size equal to n? You could keep doing that. But there is a better way. Now listen to me very carefully. Now this is a very, very important part, and it is very important to understand details like this in BFS. So what I'm going to do is I'm going to add another number, length equal to 1, because initially I've already pushed 1 digits, right? So this is basically my level. So I've already added 1 level. I've already pushed 1 digit into the queue, right? So now when I am inside the queue, what I'm going to do is I'm going to add a for loop for int, basically I equal to 0, I less than what? Whatever is the size of the queue and I plus plus. Okay. Now note something very important over here. Why is this basically? Why have I written like this? So this while loop will go on till my level becomes equal to n. Till my level becomes equal to n. This is that I am just in that level only. I am going through all the queue elements in that level. For example, initially I have pushed 1, 2, 3, 4, 5, 6, 7, 8, 9. So the size would be what? The size would be 9. Correct? Now I will start picking up each of them. I will take one and I will push the next. I will suppose push 18 if it is possible to push. If I take out say 3, I will not push if it is not possible, right? So basically I am pushing the elements for the next level. But this makes sure that I am going through all the elements in that level. Elements in a particular level. So in this while loop, what I am doing is I am increasing my length or my level, and I am adding a check that I will keep going through this while my length is less than n. As soon as it becomes equal to n, I do not need to push the next time. Note that it is not less than or equal to n, it is less than n. Why? Because when it becomes equal to n, if I push it once more, then that means I will add for n plus 1. Right? See, when my length was 1, I have already pushed 1 element. So when my length is n, I have already pushed n elements. Right? If I push one more, it will become n plus 1. So these details are also important, and not less than or equal to, but less than. Now there is one more important point. Let's see whether this is going to work or not. So firstly, I need to write q.size, and also in the end, in the queue, whatever elements I have are all of length n. So I need to obviously fill my RES, right? Because I'm returning RES, I'm not filling it anywhere. In the end, after going through these levels, whatever elements are there are all of length n. I have made sure that I have popped the rest of them. All the elements are now of length n. It will be clearer when I dry run. You can just go to this time limit. I will be dry running it after writing the Java code as well. So don't worry if you are overwhelmed. We will be writing this code so many times, you will get used to it. Okay. So what I need to do is I need to keep popping the queue and fill the RES. So while my queue is not empty, what am I going to do? I am going to push in RES the queue ka front. Whatever is there in the front, I am going to put it, and I am going to pop the queue. So one element I am taking out and putting into the queue. So now the question is this going to work or not? Think about it yourself. I am telling you it is not going to work, but let's run it and see, is it going to work or not? So here you can see it is not working. Sometimes I am getting the number of digits as 2, sometimes I am getting it as 3. I put the check of level, right? So why is this not working? Think about it. A very simple thing is that I have added q.size in the for loop, and within the for loop I am actually changing the size. That doesn't make sense. I am pushing and popping it while I am using the 𝐞𝐫 So what size I want? I want the size that I had when I entered into the while loop. So all I have to do is I have to do this s equal to 𝐞𝐫. I am just taking a variable, and here I am going to say I is less than s, and now it should work. Let's see. This is working. Let's submit it and see. Awesome. So if this part is not clear, it is fine. Don't get overwhelmed. We'll be doing this so many times. It will get clearer. But I will also be dry running this and it will become clearer. So you can just go to this time and see the dry run. But to tell you again, the number of elements that are there in that level it is there when I get inside the while loop. Like for example, in the starting it was 9, okay? In the next level it is 4. Now, if I'm changing while pushing and popping, then I'm basically messing up with the size, right? Then I'm messed up with the level. Let's dry run and see at this time. For now, I'm going to be writing the Java code. So we're supposed to return the integer array, but we do not know the size of it. So I'll be using an array list and then converting into the integer array and then returning that in the end. So let's get started. List of integer res equal to new array list. And I'll be forming return res and I'll be returning that. So I'm just calling return res. This will be new integer and the length will be res dot size. Now, so this is just the boilerplate code. Now let's get started with the DFS code. So this is the res that I'm supposed to form. DFS is nothing but simple recursion. So here you can note it is not like I'm forming a graph as such. I'm just going to be using the connection between that to see, okay, this is a neighbor or not. So what am I going to do? I'm going to do the recursive call first. First that I need to do is fill the first digit of each number. Now what is the first digit of each number? It can be 1 to 9. Note that it cannot be 0. We have to think of these cases. So I am going to write a for loop. I am calling it number. You can call it absolutely anything. The initial number is going to be from 1 to 9. And I'm going to do num++. And I'm going to call a function which I'm going to call DFS. You can call it literally anything. You can call it helper function. Now in this DFS, what are the things that I need to pass? First thing that I need to pass is the number, the current number that I am considering. Then I need to pass the n value. Now n is the length of the number, the final number that you need to have. You have already added one digit. So now your expected length has become n-1. You are going to a smaller subproblem now. Initially your length was n. You have already pushed one digit. So now your subproblem is what? Rest of the digits that you are going to include should be of length n-1. K is going to remain same. You are going to fill the res. So let's write this function. I'm going to keep it private. And do I need to return anything from this? I am just filling the res itself, right? So I do not need to return anything. So that is why I'm keeping it void itself, DFS. And I have passed the number. So number. I have passed the n. So this is the length from whatever subproblem I have. This is my n, right? This is my k value. And I have passed the list of integer res that I am going to be filling. Now what we are doing is a simple recursion. In recursion, what do? I move to a smaller subproblem, but as I go to next subproblem, I also need to know that where do I stop, otherwise I'll end up in a forever loop. I need to have a terminating or a base condition. Here when will be when the terminating or base condition? Now with every recursive call, this n is reducing, right? Because it is n-1. Further, suppose it was say initially 3, then it became 2, then it became 1. When will it stop? When should the recursion stop? When my n becomes 0. Basically, I have added all the digits that had to be added. I have added n digits. So initially, I had added 1 digit, so it became n-1. Then when I will add 2 digits, it will become n-2 and so on till my n becomes equal to 0. So when my n becomes equal to 0, that means that my number is of the length that was expected, right? N that was expected. Now this is, you can rename it to something else also. This is like new n or the leftover n. Basically, this is the n for this subproblem. When n becomes 0, this number is of the length that we wanted, okay? So now I am ready to put it to res. So in this, add basically this number and I can just return from here. So this is my terminating condition or my base condition. Now we will see what will be my next recursive call. So whatever number I am passing, note that initially I am passing single digit number like 1, 2, 3, 4, 5, 6, 7, 8, 9. But in the next recursive call, it could become say 81 or it could become 92, right? So whatever that happens, so now suppose my subproblem is 92, my number is 92. Now to add the next digit, I need to consider the last digit of this. Whatever number I have, it could even be 929 if my n that was given was 4. Now I need to consider the last digit of this. So I need to first take out the last digit. So I am going to take like this, that last digit will be equal to what? N mod 10. So now I have the last digit. In my next iteration, I need to do either this last digit plus k or minus k, correct? But while doing this plus k or minus k, I need to make sure that whatever my new digit is formed is between 0 to 9, right? Otherwise, it will either become negative or it will become a 2-digit number, which is not correct. I need to add digit wise only. That is basically my connection between the graphs, between the two nodes. So I am adding a condition to make sure that I am only going to my neighbor node. Okay, so how do I do that? That if my last digit plus k is less than or equal to 9. Now note over here that I just need to put the check less than or equal to 9. I do not need to put the check greater than or equal to 0. Why? Because I am going in the positive direction, so I will obviously have a greater number only, right? So I just need to have this check. And if that is the case, I am going to call the DFS function. Now again, what will be my new number? Whatever the number was, I am going to do into 10. Why? Suppose it was 29. I am going to do 29 into 10. If it was say 81, I am going to do 81 into 10. So I have 810 now. Now I need to add this 1 plus 7, right? Which is what? It is last digit plus k. So this is my number for the next recursive call. So if it was 81, I did 81 into 10. So 810 plus last digit plus k. Last digit was 1 plus k became 8. Okay. So now n will become n minus 1 because I have added one digit. So leftover digits, k is going to remain same, res is going to remain same. The same thing I need to do for minus k as well. So if last digit minus k is greater than or equal to 0, I am going to call my next recursive call. Again DFS, what will be my next number? Again number into 10. So if it was say 29, 29 into 10 became 290 plus last digit minus k. 9 was my last digit. 9 minus 7 became 2, right? So it will be 290 plus 2. So 292. And leftover digits are n minus 1, k will become same, res will become same. So now we are actually done writing the code, but there is one edge case that you are supposed to think of. Now for thinking these edge cases, you need to think of the constraints. Very carefully think of it. What edge case are we missing? Think of it. Now here k can also be 0. What will happen when k becomes 0? Suppose my n that is given to me is suppose 3 and k is 0. So what will be my answer? My answer will look like 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4 and so on. So now note over here, when I do 1 plus 0, it is again leading to 1. 1 minus 0 is also leading to 1. So if I do this, if I write this code, actually I would have had the same answers 2 times, right? 1, 1, 1, 1, 1, 1. Now these are the things that you're supposed to ask your interviewer. In this question, we are not supposed to return the repeated answers. So if I actually run it and show it to you, here this has worked, but now in the test case, if I add k equal to 0, it is not going to run. So all the test cases won't pass. So you have to think of the edge cases yourself also. See here, I am getting 1, 1, 1 so many times, 3, 3, 3 so many times. So what do I need to do? If it is k equal to 0, then I need to call it only once because this number and this number becomes the same thing because plus k and minus k is the same thing. So before calling the next call, I am going to do if k is not equal to 0 and this. Now note that I could have called it in any order. Then in just I have to avoid the second call, just that, right? Now let's run it. Now it is working for k equal to 0 also. Let's submit and see. We have passed all the cases, very good, but we should also know how to write BFS code of this and that's what we are going to do now. Coming to BFS, so I'm just removing the DFS function and we are going to reuse this. And instead of calling the DFS function, what do we need? We need to be adding the first digits to the queue. So let's form a queue first. For BFS, we need a queue. So queue of integer itself, right? Why integers? Why not any specific node? So here for both DFS, BFS, we have not actually formed the graph. We are treating each integer itself as the node, correct? So that is the reason. Linked list. And now each number I will be adding it to the queue. What do we do in queue? We just keep going like while queue is not empty. We will keep popping the first element and then push the neighbor nodes. Here the tricky point is that here one more condition is given to us that n is equal to 3. How do we make sure that when do we stop? Here if we keep doing BFS again and again, then firstly we'll have all the elements of size 1, 2, 3, then when will we know that okay we have reached the size 3 and now we need to stop and we need to push it to the res. So how do we do that? If you think about it, think about how the tree or the graph is going to look like. When you have just one element, so you are at basically level 1, either it is 1, 2, 3, 4, 5, 6, 7, 8, 9. Then from 1 you push 8, then it becomes 18, right? So it is the second level of the tree or the graph. Then 18, then 181 becomes the next level. So you're going level wise. So when you are at level 3, basically you know that you have added 3 numbers and now you need to stop. So we will be dealing with the concept of length or level, and we have to check that, okay, now the length or the level has become 3. Now we need to do that. But before we do that, let's try writing the simple BFS code we have written so far, and then let's see what change we would have to do to accommodate this level. So first thing I do is I take out the current number from my queue. So that is the front one. Okay, so q dot remove, if I do, I will get the front element. I have the current number. Now again, going to the node, what do I need? I need the last digit. So last digit is going to be what? It is going to be current number mod 10. So I have the last digit now. Now in order to go to the next node, I have to consider last digit plus k, last digit minus k. The conditions are going to remain same. So if last digit plus k is less than or equal to 9, only then what will I do? I will push it to the queue. So I will add to the queue. How? What will be my new current number? It will be current number into 10, right? Same how we did number into 10 over there. Here the number is basically current number. It can be 81, it can be 18, it can be 29, it can be 92, and so on and so forth. Current number into 10 plus last digit plus k. Similarly, I will put the check for minus also, last digit minus k greater than or equal to 0. Again, k can be 0. So I have to put the check that if k is not equal to 0, only then, otherwise we will be pushing the same thing into the queue, which we don't want to do. And what will be the new number? It will be current number into 10 plus last digit minus k. So this is the simple BFS code that we have written. Now what do we need to do? We need to take care of the level thing. Now listen very carefully. What I am going to do is, to make sure that I am going to the next level, I am going to add a simple for loop, and I am going to say I equal to 0. I is less than q ka size and I plus plus. And this entire thing I am putting into a for loop. So now you will say, Keerti, there is a while loop and inside that there is a for loop. Why are we doing that? So what is happening is, this is within a level. So every time in the next iteration of while loop, what am I doing? I am basically going to the next level. And this is essentially within that level, I am going to iterate through all the elements. Is this going to work or not? Think about it. And I am going to continue my while loop till when? Till my length becomes equal to less than n, not less than or equal to n. Why is that? When it becomes equal to n, if I add again, the number of elements will become n plus 1. So when I am less than n, the number of elements are already n. So I don't want to add again, right? So when it is n minus 1, I have actually added n elements already. So if I go within the loop again for length equal to n, I will basically end up adding the digits for the next level, and I don't want to do that. So these little details are very important. So now in the queue, whatever numbers are there are all of length n, right? And that is what I am going to do. I am going to add another loop, that while q is not empty, what are we going to do? I am going to keep adding the elements from the queue to this res. So res dot add q dot. Is this going to work or not? I am still saying it is not going to work. Think about it. Why? Let's run it and see. So here you can see I have a lot of numbers of a lot of digits, but I put the check of length, right? So why is this happening? So note one very basic thing. Whenever you are adding q ka size, now inside this only you are removing and you are adding the numbers. You are basically changing the size inside. That is not correct, right? You are changing the size inside that, so the whole purpose of that is gone. What if I do this? I just take out the size outside, and now when I am inside, I am changing q ka size, but this s is still same. So now I know that within that level, whatever is the size, I am going to be going through that. It is okay if it is not clear. We are going to dry run it. We are going to be writing this code so many times, it will be completely clear. Don't worry about it. Let's run it and see. So now we have passed all the test cases. Let's submit it and see. So congratulations, we have written both DFS and BFS code, but let's do a quick dry run. Let's understand the BFS part a bit more in detail. So initially what happened in the queue, we have pushed like this. We have pushed 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We have pushed like this. So inside the while loop when I come, my q ka size basically s is 9. Now I have a for loop to go through each of these elements one by one, and I'm going to see, is it connected, does it have a neighbor, and is that valid connection, then I'm going to put it to the queue. So here for 1 I can see 1 plus 7, so I put 18. 1 minus 7 doesn't make sense, so and then I remove this, right? Now if you see within this for loop only, right now this is same, right? For 2 also, suppose I push what? I push 2 plus 7, which is 9. Similarly for 3, now 3 plus 7 becomes actually 10. I cannot push anything. So here what happened, that I removed one element from the queue, but I did not add anything to the queue. So I am changing the queue size while I am inside this while loop. So I need to take care of this as outside itself. So now what I'm going to do is, I'm going to keep taking like this, that for 4 there is nothing to be pushed, for 5 there is nothing to be pushed, for 6 there is nothing to be pushed. Then again for 7 it becomes 7 0. For 8 it becomes 8 1. For 9 it becomes 9 0. Now I am done with all the 9 elements. Now I am going to go to the next iteration of the while loop, and my S is going to become what? It is going to become 1, 2, 3, 4, 5. Now S is 5. And then I'm going to start picking these elements one by one. So if it is 18, I can now push what? I can push 181. Similarly, I will pick up 29 and I will push what? I will push 292. Similarly, I will push 707. Similarly, I will push 818. Similarly, I will push 909. So initially the length was 1, and here when I change like this, my length became 2. So in this while loop, my length became 2. I already have the numbers of length 3. Now when my length becomes 3, I don't want to add again. Now I am done. I can just take out this queue and put it to the arrays and I am done. So now I hope it is completely clear. I hope you like the video. You have no idea how much effort it takes to write both DFS, BFS code in both C++ and Java. If you think I deserve your appreciation, please do consider subscribing and please do share it with your friends. Check out Edu courses. You have no idea how much it will mean to me. Thank you so much and be consistent. See you next time.